mess with the code I give you, so then you can learn what's going on. So the best way to, if you watch the tutorials, you will see that the best way to learn MATLAB is to mess with it. Okay, so I read this code line by line, and here I'm defining the values of variables. So what I can do is I can right click the line that I select and do evaluation. So you see that it tells me the variable phi diff is defined as 50 and theta diff is defined as 80, but I don't want it to show, so I use the semicolon there. Okay, and now I don't wanna see it, so I do CLC to clear from my command window. Okay, so now I have the values phi diff, theta diff, and R naught. By the way, when you read the code, you shouldn't be obsessed with the name of the variables, just like you do in math courses. So the x in example 1 is not necessarily the same as the x in example 2. So here in this script, sphere.m, this is what these variables mean. But when I move on to another script, if I see the same variable, they may not necessarily mean the same thing. So you always have to be careful, okay? All right, and what you need to focus is the meaning of these variables and use them correctly. Don't misuse the variables and the numbers, all right? And so I have 3 values, and I can use this to define a mesh grid. So suppose you don't know what this is, then you can select it and do help on mesh grid. So pop-up window, and this is, by the way, this is the same as if you just type in, oops, time for a break, but let's skip the break. Okay, so now mesh grid. So now you see that there's a window that pops up, and I can click it again. This is the same thing. It shows me the syntax about mesh grid. How do I use it? So if you read the description, you can see that when you have 2 vectors, okay, so let's do this. Mesh grid of little x and little y returns a 2-dimensional grid coordinates based on coordinates contained in vectors x and y. And the capital X, so this is the value you get in return. The capital X is a matrix where each row is a copy of x, and the y is a matrix where each column is a copy of y. Okay, so what does that mean then? Well, we can scroll down and look at an example. Okay, so here it tells you, okay, if I define x as the vector 1, 2, 3 and y as the vector 1, 2, 3, 4, 5. Okay, so now you might be asking, how do I know x is the vector 1, 2, 3 and y is the vector 1, 2, 3, 4, 5? So because I know this command. But let's say if you don't know, what you can do is you can put the same line in the code. Okay, x equals 1, 3, and let's hit enter. Don't put the semicolon, because semicolon will hide the result. So you see x equals the values 1, 2, 3, so that's a vector, and y equals 1, 5, and you see 1, 2, 3, 4, 5. Okay, so that's what I meant. And you can even try different values. What if x equals 2, 4? And now you can think, what are you gonna get? You will get 2, 3, 4. Okay, so basically it's all the integers from the number 2 to the number 4. Okay, and so this is like a partition. So say if you're on the XY coordinate chart and you have the partition along the X coordinate, so you have 1, 2, 3, and along the Y coordinates you have the points 1, 2, 3, 4, 5, and using this you're gonna be able to create a grid, and now you have points on the grid. So you can see that the XY will return the coordinates, the XY coordinates of the grid. So you see I have 1, 1 as the coordinate for my first point, 1, 2 is coordinate for my second points on the grid, and so on. Okay, so now with the grid, you can define a function on the grid. So this is a visualization for the example. Okay, so you have a grid on the XY coordinates, and you have a function defined on XY. So for example, this function f of xy. Then for each point on the grid, you have associated value f, and this is the visualization. Okay, so this is an example. All right, and then I continue, so I have multiplications. X is the vector matrix defined by this formula, and then I have this line. So okay, let me stop here, do clear all and CLC. So let's start over again. Okay, so now I'm running these variables. Okay, so I have phi as a matrix, 81 times 51 matrix, and such, and so on and so on. Okay, so let me run this line and see what x is. So evaluate the selected part. You can see the x is this 81 by 51 matrix. Okay, so now let me run this. Wow, now it becomes a vector. Okay, so it is a 51, 31 times 1 matrix. So technically it's just a vector. All right, so now you may be a little bit confused. So let's do an example. If I have a matrix 1, 3, 2, 4. Okay, let me show you what it looks like. So I'm not putting it in my column. All right, so I have a 2 by 2 matrix 1, 2, 3, 4. Now if I do A equals A parenthesis column, and you can see it's being lined up. So it's the first column and then the second column. Okay, let's do one more. So if A equals, now let me do 1, 2, next row 3, 4. Let me show you. So you can see it's 1, 3, 2, 4. Okay, so if I do A equals this, A this. Okay, so based on the previous example, you will see it will give you a vector that's basically the vector you get from stacking up all the columns. Okay, so what are you expecting? You're expecting to see 1, 3, 2, 4. Let's hit enter. So you see 1, 3, 2, 4. Okay, so you don't wanna just run the code and say like, oh, let me look at variables, because this is like too many numbers. It's hard to keep in track. So you can do a small example like I did. Do a toy example to see what you actually have, because it's hard to know what we are doing when we have like large numbers. Okay, and for example here, what is my data? Okay, let me run this. So you can see my data is a basically 4,000 by 3 matrix. Okay, so now if I do size data comma 1, what does that mean? So when you do evaluate, so you see when I do evaluations, it also, this line also shows up in my command window, because that's the command I ran. So you see now it returns the number n equals 4131. So what is your best guess? The size of data comma 1 tells you the number 4131. So it tells you the size of let me see, columns, rows. It tells you the size of the rows in the matrix. Okay, and you can also try, what if I run size data command 2, it gives me 3 number of columns. Okay, and you can see, what if I to do size data, what is gonna return? And it gives me 4031 3. So it does tell me the number of rows and number of columns. Okay, so another way you can do is to again use the help session. Oops. It doesn't give me what I want, so let me just do size. Okay, so you will see here it has the description of the command. So size A returns a row vector whose elements are the length of the corresponding dimensions of A. And then if you scroll down, you will see examples. And of course, you can also mess with the command like I did before, so then you can see what's going on. Okay, all right, so let's do this again. If I have, let me use the toy example A we have. So A is the vector 1324. Let me do size A1. So what are you gonna get? You're gonna get the number of rows, so that should be 4. Let me hit enter. Yep, we get 4. Okay, size A2, and I get 1. If I just do size A, I should get 41, like that. Okay, so this is how you play with the code.